Good morning. Very cold in the shop today again. So I don't know how much I'm going to get done. So we're going to call this part one of the BUCHLER high voltage power supply here. And I found that the neutral is fused. Why, I don't know, but it is fused. Okay, what I did find is what looked like a black wire under the chassis, grounded. It's actually green, but it showed black under there. So we'll go back under there and show that again. So that was correct. However, the neutral is fused. And you're asking why the plug is off? Well, come to find out, the neutral, when I put a continuity check from this pin here to the neutral wire at the other end of this cord, at the end of the power supply, where it goes into the power supply, I was getting intermittent readings, anywhere from 20-some ohms down to a half ohm when I wiggled this pin. This is the neutral side right here. The hot side was okay, and the ground was completely all the way through. So when I took my meter and went on the ground pin to the chassis, I was getting the correct, half ohm or so, thereabouts, 0.7 ohms, somewhere around that area. So I had a bad pin on the plug, so I had to cut the plug off. The wire is good, so there's no point in taking the wire and replacing it. So we're going to go and get a close look at the bottom of the chassis. Now another thing too is this power transformer is missing nut and screw in here. Everything was loose. I had to tighten it all up, but I didn't thoroughly tighten them. Everything's all loose here. So it needs a major tightening up here. So it's still very cold in this shop, but let me turn this thing over and we'll see what's under there. But before I do that, what I did do is I have my cheetah cord here, okay? It's not a grounded, it's a polarized plug from an old extension cord without a ground on it. So I have my hot and my neutral here, and what I did is I connected it up here to the black and the white to the white. Of course I didn't connect this because it's not available in this cord, and of course the fuse was on the neutral side. So going to the DIN bulb, so I can either stick a plug on this and wire it with the black here and the white here, and the ground still here, of course, so that it'll be proper underneath. So let me go underneath here. And before I do, I could change the whole cord, but let me show you something close up here using the JVC camera so it'll give some nice close-ups. Hang on. Now you see that ground there, it looks black to me, but it is green. It is green. So there's not two blacks and one white like I thought it was. But it sure changed color. As you look at this wire at this end, where I cut the plug off, you can plainly see that that is a green wire. So putting an ohm meter on that green and going to the chassis, I get about a half ohm, so I'm correct there. Now if you look here, I gotta get this thing out of the way here. If you look here, you see the strain relief here? That looks like factory, okay? Here's the power switch. Now you can see how these wires are here. They're all squared off and everything. Very neat wiring. So that appears to be all factory. It's all factory there, okay? Right now I'm at the stage of tracing this thing out, and the black wire, which is here, which is the hot, but the way they got it wired, this part is correct, but this is not. Okay? I'm trying to examine this connection here to find out if that's factory. I really can't tell. On the power switch, got the hot wire coming in, and you also got another lead. You got apparently two hot wires coming up, and this is factory. You can see how this is wired here. So it's a double pole, double throw switch, but it also has a resistor in it. So I don't know whether they are turning on the high voltage at the same time, because this is your power switch here. So when you turn that on, it's a double pole, double throw switch. Normally, you'd be switching the hot and the neutral at the same time, switching them off, which is a good idea. So, I'm not one for draw. I can try. I've never done it before, but I've never tried to draw out a schematic so I can see what's going on and figure it out by way of schematic, but I might try doing that off camera. So I got a lot of tracing out to do. We're still missing a bolt in the power transformer, so before I do anything else, I want to take care of that, because that power transformer is pretty heavy there and it's hanging, and I had to push it down because the bracket was bent and the transformer was about 3/4 of an inch off the chassis. It's no longer that much now, but it got bent in shipping. Everything got banged around really bad. I'm surprised it didn't bust the meters. Okay, what I'm going to do is to put my cord, my cheetah cord here, which don't have a ground, of course. We're going to put it through the isolation now. We know we don't need the dim bulb. We're going to come through that and set the voltage on this. We'll connect it up to the end of that cord there. We'll get all that connected first, and then we'll turn it on. And what I want to do is to find out this neon bulb here, whether that's a pilot light or is it a light that might flash when the voltage gets up to a certain point. I moved the variac all the way up to the top, so we should be getting out about close to 500 volts. And I traced these wires out, and it appears that the neutral and the hot are switched, which is good, but I think what they did here is this was probably fused. This probably went down here, and they put a piece of heat shrink on. That can't be factory. Somebody must have changed it. But why would they not fuse the hot and fuse only the neutral? So normally these should be unsoldered, put some heat shrink in there and butt them together, and that should go straight through. And this should be fused, the hot side should be fused. But I got more tracing out to do here. But what I want to do now is I put some screws in there and tighten this transformer up. A little smaller than what I wanted to use, but it'll hold it. And it's still very cold up here, and I can't really think straight in the cold. I didn't check the temperature, but I bet you it's not much over 40 degrees in here. So I'm going to get this connected up here, and I'll be right back. Okay, we're connected. Not exactly a safe situation, but it's out of the way. It's in the isolation, and we are going to set it to output. Variac is down. Now the unit is off. I got to get my face on top of this meter, so you have to excuse me. Let me set this, and then we're going to go check the current draw when I turn this on. Okay, what I've got here, I'm just verifying my meter output. I got the AC output monitored on my DVM right here. It's a Rube Goldberg, I know. I don't recommend, don't try this at home. We're putting out 120 volts right there. Now we're going to turn the unit on. Before we do that, we're going to check the wattage. We're going to turn the unit on. Let's see if we're putting out any voltage. No, because we ain't got the 5U4 in there. Hang on. I had to take it out to put the screw in there. That looks lopsided. I don't know. I don't know what happened. Okay, 120 volts. We're putting out. Now we're going to check the current. First, we'll set it right here. It might require more current, and we'll just up it to the next one if it pegs the needle. We'll turn it on. Oh boy, we pegged the needle here. We got to shut it off. I had the Variac turned all the way up. We don't want to put full power on this because that electrolytic in here has not been changed yet. Boy, that power transformer is leaning, but the screw was missing on this side. Well, we'll work on that later. I don't know why. Okay, let's turn her on. Oh, she still pegs. Okay. She's putting over 500 volts out, so we got to turn that Variac down again a little more. It's hard to work with it. It'd be nice if I can get the Variac on the panel here, but there's no way, even if I took the pilot light out and put the Variac, it's just not enough room in the chassis. That's probably why when they made this thing, the Variac was on the side of the cabinet. It'd be much better if it was on the faceplate, but that's not going to happen. All right, let me get that voltage down a little bit here. Yeah, she's all the way over. Got some scribbling on the bottom right corner. Some engraving in the glass there. It kind of distorts the reading, but anyways, we're up there. I don't like to leave it there too long at that voltage, but we're only drawing a little bit of current. That's why I question that fuse in there. However, there's no load on this thing yet. We're feeding it right now 119.4 volts right now. That's my line voltage. I'm lucky to have that much. We don't even have that much most of the time. I'm feeding it with 102 volts right now. And you can see it's under 500 volts. So I just figured I'd experiment with that a little bit. So we're going to get it back up to about 115, 118, somewhere around there. Little below 120 because I don't get that voltage out here anyways. So we're feeding it with 117.5 volts right now. That's what we're reading on the PR57 here. And drawing very, very little current. So everything seems to be good, and the filter capacitor obviously isn't in bad shape, otherwise we'd be drawing a lot more current. So we can try putting a load on this, because I don't know if the milliamp meter even works. There's only one way to find out. We'll just put a load across it. What I have to do is experiment, because I probably put a resistor across this. We're going to shut this off right now. Now this meter might be, because it's standing on end like that, it might be reading high, because I don't think that's static. I think what we're going to do is put this back up on the bench the proper way, and we're going to put a light load on this here. We'll have to experiment with that. Well, she's drawing roughly about 12 milliamps, I would imagine. But when I put this up here, I can change that. It doesn't change the voltage. The radio is connected, so the voltage is pulled. It's roughly about 60 volts going into it. So it's not quite enough. So it's similar to the homemade power supply I made, you know, the Rube Goldberg thing. That was just a bunch of wires and a bridge rectifier. So I need to get more current out of this, and that I understood. I would have to do anyways on this. So it's going to have to be modified, and what I'm going to try to do is to draw a schematic out. I've never done it before. I usually work, when I build things, I just build them, and that's it. I usually draw a rough schematic and then put it together. But I got to trace this whole thing out so I can find out how I can up the current on this. Anyway, this is going to take a little while to work on it, and it's still very cold in here, so I'm not really into it yet, so to speak, because it's just damn cold, and I'm trying to keep warm, and my hands are freezing. Later in the week, it's supposed to get better as far as temperature is concerned. Who knows? But this garage radio is drawing current off the B+. But the radio doesn't do anything. It's stone dead. So that's just the way it is, I guess. It's a shelf queen. Beautiful radio. I really like it. You've seen it before. All right. So we'll pull this off. We'll see what the voltage goes up to. 76 volts. So we need to beef this up and get more current out of it, and that's what we got to do. It would be so much easier if I could get a schematic on it, but it's not available. So there'll be more on this. coming up on a video. I figured I would just put this out. I'm cold now. I'm going into the house. I got to get warmed up. Talk to you later. Thanks for watching.